Hey everyone, welcome back to the College Algebra playlist. In this video, I'd like to take everything we've learned about the transformations of functions and even and odd functions and apply it to some concrete examples. Alright, real quick before we start though, I just want to mention that I'm going to be committing to a new upload schedule. Alright, I'm going to be releasing new videos every Sunday, Tuesday, and Thursday. Alright, so make sure you're subscribed so you never miss a video. And make sure you've got that notification bell turned on. All right, so let's dive into the video. Okay, here we go. Example 106. Here we're asked to describe how the graph of the function g of x is a transformation of the graph of the original function f of x. All right, so this is a multi-part problem. All right, so let's start with part A. G of x equals f of x minus 5. That's what we have here. All right? We're subtracting 5 from the entire function f. All right? Subtracting it from the outside of the function. So that tells me that this is a vertical shift down by 5 units, right? If we plug something into the function, that's a horizontal transformation. And then if we do something to the entire function, right? Like here we're subtracting 5 from the entire thing. That's a vertical transformation. All right? For part B, we have g of x equals f of negative x. All right? We're plugging a minus x into the function f, all right, which results in a horizontal reflection, right? This is a reflection across the y-axis. All right? So that's what we have there. And finally, for part C, we have g of x equals 3 f of x, all right? So we're taking the entire function f and multiplying it by 3. So that sounds to me like that's a vertical transformation. And since we're multiplying, it's a vertical stretch. All right, this is a vertical stretch by a factor of 3. All right, let's move to the next example. Here we're asked to write a formula for the function obtained when the graph is shifted as described. All right, the function f of x equals absolute value of x is shifted down 3 units and to the right 1 unit. Okay, so we have 2 shifts happening here. All right, 2 shifts that we need to handle. So let's hone in on these parts here. All right, it's going down 3 units and it's going to the right 1 unit. All right. So when we shift something to the right 1 unit, that's what happens when we plug x minus 1 into the function. All right? And when we shift down 3 units, that's what happens when we subtract 3 from the entire thing. All right? So we need to incorporate both of these transformations into one function formula. All right? When we plug x minus 1 into the function f, right? We have the absolute value of what we're given, right? So we have the absolute value of x minus 1, and then we just need to take that whole thing and subtract 3. Okay? So this is my final answer. G of x equals the absolute value of x minus 1 minus 3. Okay, great. Moving on. Here we're asked to sketch a graph of the function as a transformation of the graph of one of their parent functions. All right? If you need a reminder of what parent functions are, go check out my Introduction to Functions video. All right, I'll include a link in the description. But basically, this function here, what we need to do is look closely at it and figure out what's the simplest possible operation, right? What's the simplest parent function that can represent f, right? And that we transform to end up with g. All right? We have the absolute value of something plus something. All right? So it looks like we need to hone in on the parent function f of x equals the absolute value of x. All right? When we plug an x minus 1 into that function, that's a shift 1 unit to the left. And then when we add 3 to the whole thing, that is a vertical shift up 3 units. All right? So take a look at this curve, right? What we've done is we've shifted the whole thing 1 unit to the left and up 3 units. All right? So this is the graph that I'm looking for. All right? Let's move on to the next example. Here we're asked to write a formula for the function g of x. All right? So this is a parabola, and we know how to deal with parabolas, right? The parent function that we need to hone in on is f of x equals x squared, right? This blue curve here, okay? What are we doing to this formula to end up with g? That's the question. Well, we know that a vertical shift is defined as g of x equals f of x plus k. And if k is a negative number, then that means it's a shift down, right? And that's perfect. That's exactly what we need, right? Because this blue curve has been shifted down by 3 units, okay? And not only that, but it's also shifted 1 unit to the right, okay? So a horizontal shift is given by g of x equals f of x minus h. And if h is a positive number, that means it's a shift to the right. Okay? So putting those two transformations together, what we have is g of x equals x minus 1 whole thing squared minus 3. Okay? So when we plug x minus 1 into the function f, right, that's a shift to the right. And then when we subtract 3 from the whole thing, that's a shift down by 3 units. Okay? So this is my function formula. Here we're asked to do the same thing, right? We need to come up with a formula for the function g. All right? What function does this look like? This curve looks familiar, right? We've seen this before. Let's hone in on the function f of x equals x cubed. All right, that's the parent function that's being transformed to end up as g. All right? Looks to me like the blue curve has been reflected horizontally, right? It's been reflected across the y-axis, and then it's been shifted up by 2 units, okay? So there are 2 transformations happening, and we need to incorporate both of them, all right? A horizontal reflection, this is what we have, right? This is what we get when we plug a negative x into the function. And then a vertical shift, right? We've seen this before. That's just when we add some constant to the entire function, right? So incorporating both of those transformations, we end up with g of x equals negative x whole thing cubed plus 2. Okay? We plugged a negative x into the function f, and we cubed it, right, to get that horizontal reflection. And then we added 2 to get it to shift up by 2 units. So this is my final answer. Okay, great. Here we're asked to determine if the function f is even, odd, or neither. All right? Let's recall from the previous video what it means for a function to be even and what it means for a function to be odd. All right? A function is called an even function if, for every input x, we have f of x equals f of negative x. All right? And a function is called an odd function if, for every input x, we have f of x equals negative f of negative x. All right? So what we need to do is take f of negative x, right? Take that and simplify it and see if we end up with the same thing that we have up here. All right? That's how we check if it's even. And then we take negative f of negative x and simplify that to see if we get the same thing up here, right? That's how we check if it's odd. Okay? So let's start by checking if it's even. All right, let's start with f of negative x and see what we get. Okay? When we plug negative x into the function, we get 3 times negative x whole thing to the 4th. All right, that's what the function says to do. It says to take what you're given, take what you're given and raise it to the fourth power, and then multiply the whole thing by 3. All right? So we have 3 times this to the fourth. And this thing to the fourth, right, it's negative x being multiplied by itself 4 times. Okay, so we have 4 minus signs. And since 4 is an even number, that means that the final result is positive. All right? So we just get 3x to the fourth. And look at this. It's exactly the same as this formula up here. All right? Which means that f of x equals f of negative x for all values of x, which means that the function is even. Okay? And when we graph this thing, we can see that it's symmetric about the y-axis. All right? That's a characteristic of even functions. Okay? Let's move on to the next example. Here we're asked to determine if this function is even, odd, or neither. All right? So let's just jump right into the formulas and see what we get for f of negative x and negative f of negative x. Okay? F of negative x is equal to this. All right? We're taking negative x and we're plugging it in here and here. Okay? And this simplifies to negative 1 over x minus 3x. All right? So let's take a look at this formula and compare it to this. All right? We can see that they're not the same. Okay? F of x does not equal f of negative x. Therefore, f is not even. All right? So what we need to do next is erase all this and check negative f of negative x to see if it's odd. All right? One thing that's nice about having a digital whiteboard is that I can erase with a click of a button, right? So let's check negative f of negative x. All right? What I want to do is put f of negative x in brackets, okay? And I also want to color code it blue, okay? We already found on the previous screen that f of negative x is equal to this business in blue here, right? This business in the brackets, okay? So to simplify this, all we need to do is distribute this minus sign to each piece in the brackets here, right? Distribute a negative 1, okay? And when we do that, we get positive 1 over x plus 3x, all right? And that's the same thing as the original function formula, all right? Which means that f of x equals negative f of negative x, which means that the function is odd, okay? And if we were to graph this thing, we would see that it's symmetric about the origin, all right? And this looks a little goofy, right? Usually I like to label my functions above the curve, but I ran out of room, right? So I labeled it down here. But no worries, this is what the function looks like, and we can see that it's clearly odd, right? It's an odd function. Okay? One more example. Here we're looking at the function f of x equals x minus 2 whole thing squared. All right? This time, instead of making an algebraic argument, right, instead of simplifying f of negative x and negative f of negative x, I just want to graph this thing, look at the curve, and make a graphical argument. Okay? How do I know what this function looks like? It's because of transformations, right? This is what we've been studying. F of x equals x minus 2 whole thing squared is clearly a horizontal shift 2 units to the right. And the original function is x squared, right? We know what that function looks like, so we know what this function looks like as well. It's just a shift 2 units to the right. And we can see that the function is not symmetric about the y-axis. All right? It's not symmetric. about the y-axis. Also, it's not symmetric about the origin. All right? So that means that the function is neither even nor odd. All right? That does it for this video. Thank you for watching, and like and subscribe.